link analysis software is an AI software that helps create connections in between a group of individuals based on their data.
Oh, it automatically advances.
Does it? Oh,
After the 20
20
seconds.
seconds? Oh, I'm sorry.
So I don't know. I don't know anymore. We have to start it again.
Okay.
Okay, what is my You want to keep going. What? Oh, and then I wanted to say that I'm going to take, this will take up some of your 20 seconds.
Okay, that's okay.
Yeah, some of these questions, we'll ask a few questions at the end, and then some of those questions will be on your final exam. So you want to think about the kind of the big picture stuff from each talk. Okay, link analysis software.
Okay. Link analysis? Yep.
Just
We
look
kind
at
of already covered on what a link analysis software is. It's a software tool. You can use artificial intelligence to draw links between different types of digital forensic evidence.
So one pro is that you can take a large amount of data and organize that and make visual connections in a short amount of time. Because when you are looking at any forensic evidence, obviously there's a lot, and to do this any other way would be too time consuming.
So one con of this is as software progresses for investigators, also progresses for criminals. So increased encryption can also be as a major con of this.
So, as I said before, any other way to make these visual connections would take a long amount of time. One method that was used was called visual hand cards, okay? And you can see in like TV shows and stuff, people have like pictures and note cards, and then they're taking those strings and they're making connections. That was that, and that takes too long.
So another con of link analysis software is that it lacks like human emotion and human empathy. So it can actually make biases about criminals or crime worse because it doesn't have that human filter to counterbalance that.
So one case study that used the link analysis software was the July 7th London bombings, and these occurred on July 7th, 2005, and 4 suicide bombers attacked the London Underground Railroads and a bus.
So, kind of with this, they use different computer or security camera footage to kind of link, see who was going in, who was going out. They kind of were able to use this to draw.
So also using link analysis software, once they figured out who the bombers were, they were able to use their phone records and their social media connections to figure out that they were part of a terrorist group called Al-Qaeda, and they were able to kind of make connections on who they were, what they were doing there, why they did that.
So they actually ended up using link analysis software to connect 4 suicide bombers from Al-Qaeda to these crimes. And
so using the link analysis software, they were also able to better understand the radicalization process that happens in these terrorist groups. And they were able to better understand what they needed to do in terms of counterterrorism and just how to prevent anything like this from happening.
the suicide bombers were eventually convicted and charged in July of 2000. Yeah, they were arrested on July of 2005.
Another instance where link analysis software was used was the Enron scandal, which was actually a financial way to use link analysis software to detect fraud.
So the Enron scandal is different in that it's not like a murder or an arson or anything like that. It was a giant financial crime where the Enron Corporation, the oil company, was using deceitful accounting tactics to make their profits look larger.
Due to the fact that this had been happening over years, there was a large amount of evidence that investigators needed to go through. And with crimes like fraud, it needs to happen fast so that you can stop it from happening. So because of the large amount of evidence, they decided to use link analysis software to connect these frauds.
One way they used this was in the massive amount of emails between employees and the corporation. Because there were a lot of innocent workers at Enron, but they still needed to find a way to convict the higher ups who were in charge of this. So they used link analysis software to determine who was doing what based on various emails.
So while many employees were innocent, the founders and the CEO were both charged with 45 to 24 years in prison for these crimes, all due to link analysis software.
Yeah, so as she said, both Enron's CEO, I believe his name is Kenneth Lay, or Enron founder Kenneth Lay and CEO Jeff Skillings ended up getting 45 years and 24 years in prison respectively for their role.
All of this was due to link analysis software. Without this, it would have taken them years to go through all of the financial statements, all of the emails, and detect every single thing. And even if they did do that by hand, it's very common to miss important information when you don't have something to go through all of that for you.
And these were all this is our bibliography and all the sources we use for our pictures and various talking points we had during this presentation.
Good job. I like the enthusiasm. Can I ask, and I'm sure this is maybe I already know the answer. To get all this stuff, first you have to have some evidence initially, right? To be able to
Yes.
say, now we're gonna subpoena all your emails or stuff. What did they have initially on them? Do you know? Just curious.
On the Enron?
On the Enron, yeah.
Well, on that one graph, they showed like the revenue in comparison to employees, and like everybody had like a few more employees in comparison to $1 billion in revenue. But you looked at Enron and they had like something crazy, like unjust. And then you look at their like stocks and it really wasn't all kind of matching. So that's kind of what.
Just looking at what other companies had, they're like, something's not right here.
Right, yeah.
And that was enough to. I just love it that there's something out there for white collar crime, right?
Yeah.
You would think that. You would think that. Oh, I don't know if I can remember now. Criminals are using this a lot too, right?
Yeah, that's one of the issues that's coming up with it, because as the software advances, so is technology, which means that encryption, like getting the information that's online is a lot harder, which can make it more expensive because only some people know how to get to this. Like your average investigator isn't gonna know how to decode all of this encryption to get to the information. It is making it harder and a lot more costly.
So if it is encrypted, then they can't get to it?
They
Or-
can.
Okay,
It's
it just takes
possible.
time.
It just takes more time and someone specific to get to it.
They're still allowed access
Yeah.
to all your phone records and stuff?
Yeah.
Yeah.
Okay.
Just depending on who you're going after, how, I don't wanna say smart they are, but it can make it a little more difficult.
I think one of the most interesting parts too was that they were able to see how people were brought into the radicalization process.
Yeah, I found that really interesting too. They did that by going through their social media and seeing who they were talking to, who they were doing all this, and they actually found that the bombers were connected to a lot of other people who had already been under investigation for extremist activity. And it really helps just identify, how do they go from a normal person living their life to being this extremist group bombing a subway.
Right, that you're gonna kill yourself for this. Yeah, ridiculous. I didn't do very well with the questions. Does anybody else have any other questions about link analysis? Who's like one of the main software people that puts this out, do you know? Like who's selling these products, do you know?
Honestly, I'm not sure. I mean, I could speculate, but I don't think that would be
Okay.
right for me to do.
I think it's more of like it's developed by who is using it. Because I know, I read
FBI
something
has its own.
about like the Seattle Police Department. They had their whole own link analysis software called iBase that they use for their investigations. So that's kind of telling me that it's,
They
created
have, so it's
for
like,
yourself.
it's like your telephone company, you call them and say, I want this system. And they
Yeah.
help you set it up for what you need, kind of thing.
I think essentially that's what it is.
Anything else you guys want to know about link analysis? All right.
Slide, but ours is over gas chromatography and mass spectrometry. And wait for it to change. So the gas chromatography portion is a separation technique of small volatile and semi-volatile organic compounds. And combined with the detection power of mass spectrometry, it can separate compounds, identify unknown chemical compounds, and identify trace levels of contamination.
Stakeholders. So some of the stakeholders include pharmaceuticals. It also includes food and beverage industry, scientists, environmental agencies, forensic examiners, and laboratories.
Okay. It's a very powerful method for identifying drugs or toxins, and it's highly sensitive. That is what it's very sensitive and selective. It's referred to as GCMS, just so it's easier, but GCMS can identify compounds at very low concentrations and differentiate between compounds by their mass and molecular structure. So since it can determine trace levels of things, it's commonly used in professional sports, such as like the Olympics. It's very effective at screening a wide range of drugs to ensure a fair competition.
So
So this is a case study where they were trying to find trace levels of pesticides on cucumbers, and GCMS was able to identify 12 unknown pesticides that were found.
So GCMS can also identify unknown compounds samples by analyzing the mass spectra. After analyzing the mass spectra, it is commonly used as a unique fingerprint, which helps to identify the unknown compounds. And because of this, it can help with arson cases, because up to 20% of fires end up being caused by arson. And because of this, they're able to analyze the petroleum something. Sorry, I can't remember what it is exactly. But by analyzing this, they can end up figuring out if it was actually caused by arson or if it was just an accident fire.
So this is a case study. It used HSGCMS, which is after stress due to high oxygen levels. The goal was to see if they were like reliable markers for finding out what causes the oxidative stress, but it ended up not being a reliable marker. It didn't correlate as well as they thought it was going to.
So another con of GCMS is that it takes a little while to analyze, and including the cleanup process and the training, it ended up taking a really long time for someone specialized to be able to do it. And because of this, there was a man on death row for 8 years, and because GCMS was used improperly, he ended up being on death row for 8 years for killing 2 children, his neighbors, that he didn't do anything to, because they analyzed things from a kettle, and it wasn't actually, they found poison in it, but they didn't at the same time because the cops were lying, and because they weren't actually using their evidence, they ended up persecuting him.
So, GC can't always tell compounds apart because they may have the same timing, and MS can help identify compounds, but still can't go to the level of detail. It has limits, and that gets shown in the case study of essential oils, because it's a high resolution gas chromatography and thermal classification, and the study compares how difficult it is for it to separate things based off of their potential time.
This is our bibliography.
I missed what compound they were looking for, I don't know if you know off the top of your head. That they were looking for to determine oxidative stress. Were they looking for something specific, or was it?
They were analyzing
Or just the pattern of?
yeah, I think it was the pattern. They were trying to see if they were like linked together, the compounds that were released during oxidative stress. So I don't think it was a specific compound, just like in general.
In general. 25% of all fires arson?
20.
20, okay. That seemed like a lot.
Yeah.
And the cucumber case, this was against a factory or like a farm, or?
I think it was against a farm, because they were analyzing it, the cucumbers specifically from an Iran.
I know that they didn't know that the pesticides were there until
The farmers didn't either? Or-
No.
Oh, okay.
The
Yeah.
people testing the cucumbers, and then GCMS ended up finding 12 different pesticides.
So it could have been like somebody saying these are organic, and they really had
Yeah.
a whole bunch of.
I don't think it gave information on where the cucumbers came from.
Did you have any Olympians that you knew Olympians that you researched or that were actually caught with? Just curious, you know.
Not off the top of my head.
I know
How did
the
you-
track star, like Shikai Gary, is that her name?
Yeah.
She had drugs in her system, but I don't know if they used GCMS to trace that.
GCMS, so probably, but it's interesting that they found that. Anybody have any questions? The main things again were that you can separate it, you can ID, and that you can do super small amounts, even if you have trace amounts. They can tell, you can do parts per million, just tiny, tiny amounts in GCMS. So a bunch of different range of things. I thought it was interesting that you found another case study that they did the analysis wrong, and that was the same, just like the fire that was in your text. They had misrepresented the data, and here again, they've misrepresented the data. And nobody caught it for it went on for 8 years. It's crazy. The training then, do you know what the training entails for it?
That I don't know.
I'm not sure about the training, but I know there's very limited resources for training. They have very limited opportunities to train in that area.
It's quite difficult, I know that it takes a very long time for somebody to actually be able to train and use it like well. And that usually takes like a really long time to do that because they have limited resources. So I know the people who do it, they know what they're doing, so.
Yeah, I wish you guys had an opportunity to go to the crime lab on 41. They have they have those instruments there, and the lady, she says that's what they spend half their time on is drug analysis with those instruments, and that's what she goes to court, like if she's not running the thing, she's in court testifying what they found with these drugs. It's huge in crime investigation. Anything else you wanna add? No? Okay. Good job.
Now, a polarizing microscope uses birefringent light, which is where light is passed through these two different layers of like slits, and the way that works is it sends the light like through each other multiple times, and it creates very vivid detail in the samples that you're trying to analyze. In this first case, this was the Lindbergh kidnapping. And some of the evidence that was analyzed here, there was broken glass, there were shards of broken glass from the scene. They also left footprints, maybe possibly with some dirt. And these are some of the things that you would want to be analyzing with. These are just a few of the things that you would be analyzing with polarized light microscope. Would you like to say a couple things?
I don't know about this case.
That's about the extent of my knowledge of this case.
Could you skip forward?
It'll go.
Okay.
I don't know what that looks like. It looks like a window on the right, and is that a gas can on the left? It looks
Yeah,
like.
they
It
find
looks
a,
like
they
a
find a
gas-
gas can on the scene as well.
And the Lindbergh kidnapping? Oh, you better go.
That's what I read in the papers.
Oh, okay. I didn't know. I thought it was like ended up being some wood, they matched some wood ladder to something you had in the attic or something crazy like that. And that looks like shoe prints. And that's footprints in it. Oh. And then there's a taxi driver.
Yeah, I'm really confused with what's happening right
He's like,
now.
I'm really confused.
I don't know that part. And the kidnappers turned out to be like some apartment here that
Oh.
lived nearby, right? Something like that? Or I don't know if that's even true.
This is the last slide.
Yeah, and they never did, the kid died, right? They found the dead body or something, is that what happened? Do you guys remember?
It's out in my head.
Kidnapping for ransom in the US.
The first?
Kidnapping for ransom.
Oh, I don't know, yeah, probably. I mean, it's a huge case, right?
Alright, this is Lane Williams, and he was accused of 2 murders, and he was first accused after a woman found 2 children's bodies under a bridge. He's a bad guy. And the FBI got involved with this case after another abduction happened. They didn't know who it was, and the abduction was with a 7-year-old boy, so they took it pretty serious. And this is Special Agent John Glover, and he was in charge of the case. And the first break in this case happened when the motive changed. It changed from just dumping the body in the woods to then dumping the bodies in the Chattahoochee River. I think that's how you say it. And after locating the bodies, the police did surveillance on the area of the woods and the Chattahoochee River. And they heard a splash at the area, at the river, and then chased the car that made the noise. And the car in question was Wayne Williams, but they had to let him go due to no probable cause. And he was responsible for 20 to 29 murders and was able to link him through hair and follicles, and which led to his conviction. And the trial occurred, and the biggest piece of evidence was the use of the polarizing microscope for matching fibers from the victims, and he was charged with murder and is serving 2 life sentences right now.
Now, Ted Bundy is one of the most infamous serial killers. He was killing, that we know of, between 1974 and 1978. He's confirmed to have killed 20 people, though he confessed to 30. And some of the officers working with him believe that he may have killed 100 or more people throughout his lifetime. According to the polarizing microscope, Locker's exchange principle, which essentially states that perpetrators leave evidence and take it with them. And this is important because we have all of these different pieces of evidence, and this is how the microscope works by analyzing those pieces of evidence. Some of the evidence was from his van here. There was a sort of a unique carpet inside, and this was linked to multiple of his crimes. For example, we have 12-year-old Kimberly Leach here, who is his last victim, and he left some of his hairs on her body, and she was also found with some of those fibers from that van. And he actually kidnapped her from her elementary or middle school, I believe. This is Cheryl Thomas, and she likewise, she was brutally assaulted in her home, and she broke her jaw and I think busted one of her eardrums from the assault. And she also had some of her some hairs and fibers from that van. And these are just a few of the ways in which polarized microscopes are used to put to justice criminals like Ted Bundy by analyzing those specific pieces of evidence.
And this is our sources, bibliography.
So you have 2 really good case studies. Definitely, you said mud?
Yeah, like I read that it's used to analyze like the specific grains and the specific different types of mud and minerals, more specifically.
So the minerals in the mud and hair and carpet fibers. Did you come across anything else that they use this scope with?
One of my cons was the types of glass. This isn't related to the Lindbergh trial, the Lindbergh case, but my con was that it's difficult to identify certain glasses because of the way that it's tempered, the way that it's cooled. And it's similar to like tempering chocolate, where when you melt it and then you cool it fast, it's gonna, it doesn't crystallize very well. But when you repeatedly melt it and cool the chocolate, it tempers it and it forms stronger crystalline structures. And this is kind of how the glass works, where when it just melts, it forms random patterns, and that leaves it difficult to identify because it's just a random pattern, and you don't really have anything else to compare it to.
Yeah, that's a great thing to know about the polarizing microscope, that you need a regularly ordered
You need something to compare it to.
solid. Yeah, you need order in the solid to see those different, colors and patterns in the image. There were some nice pictures also in your book of drugs. So one thing I really like about this technique is that it can even identify drugs. I mean, we don't need to use it for that because we have other things. But just the number of things it can do: hair, fibers, sunglasses, drugs, anything that's solid, regularly ordered thing. Do you have anything else you want to add to it? I think the case studies are a good thing to know for this one. Because there's a lot of information about the case studies. Do you want to add anything? Anybody else have any questions about it? No? Yeah.
Mine's like a comment, so if you guys are down in Tennessee, there's this place called Alcatraz East, and it actually has Ted Bundy's card.
His car's in there?
Yeah,
Where is it?
it's in like Tennessee, it's like around, it's one of the two, I think it's Pigeon Forge, but it's really cool. And they have like
A bunch of
John Wayne
criminal-
Gacy, like it's all like stuff like that.
Pigeon Forge.
It's super cool. I remember it being too expensive to get any, like $20 maybe.
Okay.
Bonnie and Clyde's car, a bunch of bullet holes in it on display somewhere.
I think that's there too. I have pictures on my phone, but I'd have to read into it.
I don't know. I don't know if people will go there and.
I gotta say, the 20 seconds went by a lot faster.
Doesn't it go by fast? Yeah, even for me too. I'm like, oh, it's already done. It's rather painless. Anybody else? Pigeon Forge? We should all go.
Yeah, that's true.
That'd be fun.
I don't know where it went, but we're doing facial reconstruction. The title is just
Oh.
MIA, I guess.
Peace out.
Well, it's okay. You can say it anyway. Well, there you go.
Oh.
There it is. That makes it
So we're
Did
doing
you,
it.
did you guys put transitions in the slides? Cause that might be why.
So we're doing the ethics of facial reconstruction. So getting into what facial reconstruction is a method used in the field of forensic science to reproduce the likeliness of an individual's skeletal remains, primarily used in cases of missing or unidentified persons. They were also able to do this with King Tut a little bit. That's the first picture, and then this is also like a step-by-step process of facial reconstruction. Another method is skin grafting. So it's the removal or transplantation of healthy skin from one area to the body of another. They mainly get this from your inner thigh or your buttocks area. It's cosmetically like hidden, so that's where they would go from. And then it's just less important.
Another method is the Manchester or British method developed in 1977, and it uses pegs to measure the tissue depth of the face. You can see it on here, so they can layer on the fat of the face accurately. And it's one of the most used like 3D methods today. And another method is, of course, like digital reconstruction. With the advent of like technology, of course, technology has increased or decreased the time it takes to reconstruct the face, and it can generate multiple different faces quicker than you would be able to do physically.
Okay, so how they do it, the skull is more step by step. Here's like a different process, and it's where they just like take the skull and layer it on automatically. And then it's also like the different pegs. So they put the peg on the high markers, like your call it like your cheekbones, and then around your eyes and like your chin or your jaw. And then they would also just fill that in, and then they would just fill in like the eyes, the lips, and face. And another way again is the digital. So that way they're just able to scan the skull, and they're automatically able to put like the digital markers onto the skull itself, and then automatically fill in the tissue, and then that just rescans it to get the face, and then they can also compare it to like pictures like online.
Now, a lot of what you've just seen was more so in like the modern sense. Now, if you go back like maybe about 100 years or so during World War I, it was used quite a bit differently. Some people, Harold Gillies would take skin grafts from your chest and adjust it to your face, and sometimes he would take cartilage from your rib cage and adapt it to your forehead, leave it there for a while, and then adapt it to make a new nose.
So Surgeon Harold Gillies is like I had to switch up. He's a founder of the father of facial reconstruction. He developed a new process in 1971. It's also based on plastic surgery now. It's kind of getting away, but that's just like an interesting thing to think about. And then this is the guy I confused with Wilhelm His. He done sectioning with like 3D modeling with different embryos. And then he was also able to produce very early samples of facial reconstruction with the remains of John Sebastian Bach. And that's another way he was able to do some forms of facial reconstruction. And then pros is, again, the two soldiers, they're able to like rehab their face after being in the war. It can identify remains and then also reconstruct historic and prehistoric cranial remains also. Again, going back to the first picture.
Now, one con is that it can be pretty lengthy. Physically reconstructing your face can take it's a long process. Now, with digital reconstruction, it has been decreased the time. Another con is that there's no standardized method. You can see that there's multiple different methods here that are like shown, digital and like physical, and it requires extensive skill for each one. So it can produce a different face for like each reconstruction, which isn't, according to like the Daubert standard, technically admissible in a court case. So if you're trying to use it as evidence, it's not technically admissible. So that's one con of facial reconstruction. And though it has been used in cases before, like in the Bunchy Nyhouse case, where a Finnish cartographer found a skull in the forest of farmland, Missouri, where they had to try and identify the face of the person who the skull belonged to. And they managed to figure out her race, gender, and around the same age. So they used markers like the PEG method to measure the tissue depth of her face and reconstruct her face off of that. And then they released the reconstruction of the face to the public, where they were able to find someone who was able to recognize it as her, or recognize the comparison of the face to her old friend from Thailand, Bunchy Nyhouse. And they were able to do this because of the facial reconstruction. Even though it's not an exact match, it was close enough because of the reconstruction that they were able to do this.
So this is a case study I couldn't really find a whole lot about, but this woman's skeletal remains were found in a woods near Louisiana, and so they were based on her skeleton. She was there for about 2 months to up to a year, maybe more, and they identified her as a Caucasian female, aged about 20 to 21. She ended up being 18, and with the help of a group called Faces in Louisiana, they were able to reconstruct her face and get an image comparison. In conclusion, like really to summarize everything that we've said, we talked about how facial reconstruction is a great use, although it has its cons, but it's able to change lives as well as solve cases here in the future. History goes back a long time for this, and the world continues to make the developments on it year after year. The use of facial reconstruction helps us understand and solve the past as well as impact lives here in the future and the present. And here's each of our sources, the sources that we used, where we got our images from, that sort of thing. What is the slide for each of us?
Yeah, I think so.
Here.
The time frames for me, how long to do it? Like, is it months, a year to do it manually with clay versus computer time frame? If you do it on the computer, how long does it take? A week?
I think it's like months for physical.
Sometimes it can take up to months with like manual clay because there's so much sculpting that has to be done. But I guess that also kind of depends on the artistic skill that the person has.
And the digital, how long does that take?
Well, I mean, it's not like instant or anything, cause it's not like magic, but, it's definitely far less than, I'd say like probably a month, maybe, or even less, but it's definitely a few weeks to a month, yeah.
What's that?
A few weeks to a month.
So it does take a bit then too, even with the computer modeling. I didn't think that one picture, they looked anything alike, the two, but maybe I was not seeing it?
What case study?
The second case
The
study?
second one.
What did you think?
See, I thought she was a lot more like similar compared to Bungie.
You did?
I thought it was loud.
I just didn't see the nose to me is, I guess, is what did it. And the shape of the face, but maybe the angle too. And maybe because the way they did the hair.
Well, it's important to know, like, she's smiling in that photo, and that could affect your recognizability of her.
Right, because she's smiling in this one and. Yeah. And when I saw the picture, I thought, oh, this doesn't look but different color hair, different color eyebrows.
They never-
different facial expression. It's hard to, right? How are you gonna get that on a.
The skeletal remains were found in 1980 and she was never actually identified until 2019. However, they did get suspects for the murder in 2014 and then they were convicted in 2019, 2020, that area.
Oh, they did, so they're able to get,
Mhm.
they were able to. And can you do the Dauber quick again, so you can no longer use this in court, or what was the Dauber decision?
Dauber standard, I think it was established 1990s, something, which would be after the Bungie Nighthouse case, and probably this case, right?
Probably.
Yeah, so even though it's been used in the past, like, because of the Dauber standard that was established in the nineties, it can't be used as a court, admission like now.
So you can't even present a computer generated version?
I don't know how a computer generated, would affect the Dauber standard, cause I don't know. Physical reconstruction, I guess, would be less easy to like standardize than a digital, like a computer, you can code a computer. I don't know. I mean, imagine the same principle applies, cause it's still like the same like facial reconstruction method, but I don't know.
Okay, maybe we'll have to have another court case that goes over and that, or something to see if they'll admit it again. Any other questions about facial? No, just in depth.
Which is the genetic process determining, the process of determining the genetic code of non-human organisms found at crime scenes.
Okay. All right, sorry. Sorry, I'm not ready. Okay.
Okay, so DNA sequencing other than humans is finding the genetic material and code of non-human organisms found at crime scenes.
First, I want to start with fibers. Fibers are really common in crime scenes. One of the pros is that it's really easy to transfer from one person to another. In this case, this is Roger Payne, who called the police saying that his wife was murdered when he got home. Come to find out that it was actually him who killed his wife because they found fibers on him that were correlated to her dress.
This case study is about someone that gave HIV to someone that was spreading HIV to random people while knowing he had it. Something about DNA or disease research is that. I'll finish that.
Okay, so there was a case where a cow was sired from a bull, and it was stolen by competing farmers, and they were able to recognize that cow after its brand had been taken off.
Another thing is with fibers is Bobby Joe Long. He was known to be sexually assaulting women, and by the end he was known to kill 10 women in total, but he let 2 go, and because he let them go, they found red fibers on their clothing that correlated with his backseat of his car.
This case study is about a guy who put anthrax in mail letters and sent it out. They were able to test the mail letters and the victims
we're talking about one of the cons, which is contamination. Over 40 cases were contaminated and were thought to be one massive serial killer in Germany, when it was just found out that somebody's DNA ended up getting contaminating the swabs that were used on the crime scenes.
Another with fire, this is Caleb Pugh. He was also known to be sexually assaulting women, but specifically kids. When Melissa was found missing, it actually came back that he was the one who killed her because they found blue fibers from her sweater on his suit.
This is about a case about a dog having rabies and killing 2 young children by, I believe they were bit by the dog, and yeah, sorry.
So pollen was used to trace where a woman was killed in 1994, I believe. And over 40 different types of pollen were found on her body, which were located, these trees were located in primarily Arizona, Florida, and Southern California. And one of the pollens was able to die, to show that she was in Southern California.
This is Glenn Worthshire. He was known as the 3 times dentist, but that's not why he killed his wife. It was found that she had blue fibers underneath her nails because she scratched his jeans, and that's how they correlated that he was the one who killed her.
This one poisoned pills and gave it out to their customers, knowing that because I think she was accused of something and she killed. She's trying to be known for something, I guess. That's how I read it.
In this case, they were able to trace this dog to its poop, which they were able to trace the dog to the owner, who ended up killing somebody at a crime scene. But if the dog didn't poop in the yard, then he would have never been caught.
This is Craig Fair. Fibers aren't always good. It actually takes a lot to try to correlate with, something. He was a police officer and they found a victim in a ravine. They found a piece of gold fiber on her, which correlated to his uniform.
Alright, this lady poisoned her boyfriend with a antifreeze by the car. The way how they're able to detect it was they're able to extract it from his bloodstream, and I forgot what it's called, but they're able to sorry.
No, you're good. So in 1992, Apollo Verde tree was found, I think a leaf was found at one of the crime scenes of this woman who crashed her car, and it left a botanical fingerprint, which was able to trace it to the location that the woman was.
This is the last for me. This is Malini. She shot her husband by putting a pillow in front of him and shooting him, and they found fibers inside of his skull correlated with the pillow, and they knew it was her because that was her pillow.
This case study is about a woman who poisoned her boyfriend with eye drops. They were able to find out what it was because she was prescribed those kind of eye drops.
So in this case, one singular cat hair was found on the body of a person, and they were able to trace that cat hair to one of the friends of the person that was murdered, and able to determine that he was the actual murderer in that case of DNA.
And these are the slides correlated to
From websites.
I do want to add a pro and a con to the DNA poison research. The DNA, or the disease research is a pro about it is everything's evolving, everything is growing, so it's good to have that research to mitigate further, let's say, not attacks, but let's say someone was poisoned by something or was killed by something, they're able to learn from it and use it cost a lot of money, depending on what it is. For example, like anthrax, since how deadly it is, they're gonna need their highest level of hazmat suits, which and their equipment, which can cost up to about $10,000, and they have to replace it after every crime scene or every time they have to do research on that.
But it can track the evolution, right, just like they track the evolution of the coronavirus, the different, genetics of it. And this is an area where, in terrorism, right, you can have biological terrorism, you can have people spread a deadly virus to a community, and that's hard to address. And then all the other types of DNA with the plants, with Ainsley, with the different types of plants. The animal case study's fascinating with the cow, that they knew that they stole it based on.
I feel like there's so many different types of DNA that can go into it. Like a lot of people on their slides, like, were able to like analyze like one specific field, but we had so many, like, so we had animals, we had like plants and pollen, and then we had disease research and fibers, that we wanted to get everything in with cases to explain how that affected the like investigation, rather than the exact like definition, because there were so many different type of cases.
Yeah, such a variety. So the viruses, the animals, plants, the dog poop. So there's the guy, they knew the guy was in the yard because he stepped on the poop, and that dog was there from that dog. And you can look at poop to get DNA.
I could be wrong, but I'm pretty sure that it was one of his friends.
Oh.
I could be completely wrong.
Okay. But you're gonna. I think it's interesting that they thought to even look to match his shoe to him being in the yard. So when you're thinking about exchanging things, you think of hairs and fibers, but you could exchange, if you're in the backyard, you could definitely exchange dog poop on your shoe. That makes sense.
I feel like technology is advanced for so many years that people don't necessarily just look at human DNA now. Like, they don't just look for fingerprints. Like, you have to see, like, the cat hair. Like, I don't know how he would have found that, but as good investigators, we can kind of put things together. There's actually a cat database now because of how many crime scenes they have found, like cat.
Oh, so
DNA.
cat DNA, so you can look at, you can match and see what type of cat.
Database now.
What? Yeah, that's. Does anybody have any questions? Okay. The money.
Guys, ours is about isotope analysis. And we had 3 people, but it's just me and Meredith. The other one kind of disappeared. So we tried our best to make this like kind of cohesive and share enough information.
Sorry, this a little messy.
Yeah. So this is the guy, Fred Saudi. He's like one of the first people to like classify and discover the isotopes. That's him right there. Kind of handsome, right? Alright, so isotopes are basically atoms. You remember these are atoms, you got the neutron, protons, and electrons. Isotopes focus on neutrons. Isotopes are atoms of the same element with a different number of neutrons. And it's like in the core, right? You have isotopes all over, especially in your bones, the ones like when all your flesh is gone, your bones are made. So your isotopes. You find them in all kinds of animals and trace them back to like species, time, behavior, like even where they migrated. Yeah, like right here. So you can trace isotopes through the food chain, even down from like plants all the way to animals that we eat, us, to fish. There's some examples of like some researchers, gathering that information and like putting them in a library. All right, that's the big machine where they ionize these like the skeleton dust, right? And then they start like recording the difference, I guess, after they ionize it. And they shoot it with big, massive lasers that can like vaporize things. Pretty expensive too. So there you go. So since isotope analysis is pretty new, small library. Same thing with DNA analysis. They started off small, but now we got DNA for cats and dogs. So this is a growing technology, and its uses are being used everywhere, or like trying out new things. So there's going to be a lot of investment in that. But the bad thing is that right now it's still kind of expensive. So you have no wallets. Let's say you need this for your report, but you don't have a deep wallet. Just out of luck, dude. And it also takes a lot of time. Let's say you want to like test a lot of samples from different places. You'll need a lot of time. Oh yeah, and here's my source.
Alright, so in the 70s, a body was found under an overpass in Florida. It was a female. She had a belt wrapped around her neck, and they couldn't really find anything about her. They were having problems identifying her, and so they did isotope analysis to determine that she was likely of, I think, Greek descent, and she had immigrated to the U.S. And the last update on her case was in 2021, and it was basically like an anniversary article, and it just said that like she still hasn't been identified, unfortunately. Alright, so Somerton Man was a pretty famous case. In the 40s, a man was found in Adelaide, Australia, dressed in like a business suit, and he'd been seen acting strange the previous day. And in 2015, there were like a whole bunch of theories as to like who this dude was, like how it got there. A lot of people thought he was a spy. But in 2015, isotope analysis was used to determine that he had higher than normal levels of arsenic, lead, and strontium-88 in his system. And in 2021, genetic genealogy was used to identify him as Charles Webb, a instrument maker and seamstress. And then in the 90s, a body was found near Racine, Wisconsin, which is a border town between Wisconsin and Canada. She was wearing a blue blouse embroidered with red flowers. She had double pierced ears, which wasn't as common in the 90s as it is now. In 2016, isotope analysis was done to determine that she was likely of Canadian descent, and people thought she was a runaway. And she still hasn't been identified. In November 2006, an injured man was left at South Wales Hospital in the UK. Doctors tried their best, but he never regained consciousness, unfortunately. So police snipped a bit of his hair, you see right there, and they ran isotope analysis and determined that he was of Vietnamese descent and likely a victim of human trafficking. And then in the 90s, skeletal remains were found in Burgenland, Austria. Preliminary analysis determined that she was between 25 and 35. And isotope analysis determined that she was likely of Caribbean descent, and she had immigrated to Austria a short time before.
I like the intro on talking about the neutrons, because that's what they're doing. They're just looking at different ratios of compounds. And the amazing thing is, for even though this helps forensics, they didn't solve any of these cases, right?
Yeah, that's another con is like, it can like tell you where they're from, but it's also like really, really broad.
No, but then they were all cases like facial reconstruction where there's nothing left, right? Of the bodies, it's been a long time, there's hardly anything left. And they can tell now where they're from, but 20 years ago from the Caribbean, who knows? I wonder how much effort, doing isotope analysis must have taken a lot of effort just to even figure out originally where they were from, so it's interesting that.
Yeah, actually, so if you saw on the slide, their library is expanding a lot now, because they're taking samples from like all over the world, even different parts, like the hair, one of the case studies here, probably didn't have that a couple years back, but we even have like specific parts of like, a woman's, like, what do you call it, inside the bone, marrow stuff?
Marrow, yes.
Marrow, like even parts, so we have really specific parts that we can, go into now, but it still takes time before we have a good library, cheaper.
Yeah, I like that you can trace at least 7 years back for the bone, I don't remember exactly. So you do have to know a little bit about this anyway from your case study. But maybe we'll talk about that when we do the review. We talk about 016 and 018 that I've already mentioned.
It was interesting they used it in the Somerset case, because I remember I followed that case and I didn't know that they used isotope analysis up until we were doing our research.
Okay. You follow a lot of death things. Okay. Any other questions about how to use the technique? It's okay. All right.